Hello everyone, welcome back to our channel. Let's discuss the next named reaction, that is Blaise reaction. So according to our format, what is the first component in the reaction? That is statement. If you see the statement, the reactants are alpha haloesters and nitriles. So in Blaise reaction, alpha haloesters treated with nitriles, which means cyanides, in presence of the zinc metal, it can produce as an intermediate commonly called as beta enamino ester. Enamino means en plus amine. En means we have a double bond. Amine means amino group. Amino group with attached double bond is commonly called as enamine group. The position is beta. So beta enamino ester. The formed beta enamino ester further subjected to hydrolysis with 1 molar HCl, we will come up with the compounds commonly called as beta keto esters. So simply we can say that Blaise reaction is very much useful for the preparation of beta enamino esters and beta keto esters. The reactants are alpha haloesters and nitriles. Okay. The second component is chemical equation. So what are the reactants here? Alpha haloester and nitrile. So we have taken one general compound, that is alpha bromo ester. Ester means C double bond O OC2H5. This is ester, right? At alpha position we have bromine. Treated with nitrile, the general representation of nitrile is RCN. In presence of zinc reflex THF solvent, tetrahydrofuran with 50% aqueous K2CO3, we come up with an aminoene. See, this is the ester group. With respect to the ester, this is alpha position, this is beta position. At beta position, we have amino group. And the amino group is attached to carbon-carbon double bond. That's why this is commonly called as beta enamine plus ester. Beta enamino ester. Then here it is subjected to hydrolysis with 1 molar HCl, which provides beta keto ester. Okay. The next component is mechanism. Very important part of any kind of chemical reaction is mechanism. Right. We all know that whenever the alkyl halides are treated with the zinc, it can produce as organo-zinc halides or not, organometallic compound. So the Zn is introduced between the R and Br, so produces RZnBr. We all are familiar with a compound called as RMgX, Grignard reagent. How can we represent? R minus MgX plus. Similarly, RZnBr. So R minus ZnBr plus. Here it is. R minus ZnBr plus. So initially what happened? We have taken alpha bromo ester or not? See, this is the alpha bromo ester with respect to C double bond O. This is alpha position. So here we have CBr bond. This is treated with zinc metal. So what happens? In between this carbon and bromine, the zinc will introduce. So we will come up with CH2ZnBr, organometallic compound, RZnBr. So R minus and ZnBr plus. So this bond will be subjected to cleavage. So C minus and ZnBr plus. Okay, what is the general representation of nitrile? RCN, RC triple bond N. If you see this particular moiety, comparing with carbon, nitrogen is more electronegative or not? So these pi bonding electrons move towards the nitrogen. So nitrogen carries which charge? Minus charge. Carbon carries positive charge. So this negative charge approaches to carbon to form a bond, and nitrogen come up with N minus. Here which one is removing? ZnBr plus or not? So this ZnBr approaches to N minus to form NZNBr. Is it clear? Now, RC triple bond N, because of the migration of this pi bond, the triple bond is converted into double bond or not? So C double bond N. R is connected. Here at this carbon, what is happening? The CH2 is connecting or not? CH2, C double bond O, OC2H5. Oxygen is having lone pair of electrons, zinc is having empty orbital. That's why there is a formation of coordinate covalent bond. Okay. Now, here we are observing tautomerism, the transfer of hydrogen from the carbon to nitrogen. See this. This is involving in the pi bond formation. The pi bond converted into single bond, thereby N minus and H plus. NH bond we are getting. Double bond and the same intermediate. Now this is subjected to hydrolysis with 50% K2CO3. So hydrogen will come here, OH will come with zinc. So ZnOHBr will be removed and NH is converted into NH2. So R NH2 double bond C double bond O C2H5. This is commonly called as beta enamino ester. The beta enamino ester is further subjected to hydrolysis with 1 molar HCl. The NH2 is replaced with OH. It is the enol form involving in the tautomerism again. The COH is converted into C double bond O. So we will come up with beta keto ester. So in this way, we can easily convert the combination of nitriles and alpha halo ester into the corresponding beta enamino ester and beta keto ester. Okay. The last portion in the name reaction is application. If you observe this particular moiety, we have RCN or not? Okay. In the final product, we are having R or not? Now the CN is converted into C double bond O, CH2, C double bond O, OC2H5. Simply remember that thing only. The CN is replaced with C double bond O, CH2, C double bond O, OC2H5. See this. Here we have a moiety that is represented as R and Cn. Br, CH2, COO, C2H5, Z and THF reflex followed by everything. What happens? The Cn will be replaced with C double bond O, CH2, C double bond O, OC2H5. This moiety is the intermediate for the synthesis of vitamin A. This is the beauty of Blaise product. Okay. Next, here we have a olefin with Cn. Same conditions applied, but here we are coming up with initial intermediate. What is that? Beta amino ester. So what we are observing? Cn is going to replace with this moiety. Simply write that moiety here. Consider this is R group. The Cn will be replaced with this moiety. We have attached that moiety only. NH2, C double bond O, OC. So this is an intermediate for capitimycin A. Okay. In this way, Blaise reaction is very much useful in the conversion of the nitriles into beta amino esters and beta keto esters. Okay. So simply learn this Blaise reaction. Okay. This reaction is very much useful in the preparation of beta keto ester. As far as the research is concerned, we have a popular name reaction commonly called as Biginelli reaction. In the Biginelli reaction, what happens? Aromatic aldehydes treated with beta keto esters in presence of urea oblique thiourea produces dihydropyrimidinone derivatives. So here we need a variety of beta keto esters. So according to Blaise reaction, if you have a nitrile, you can convert that nitrile into the corresponding beta keto esters. This is one of the good application of the Blaise reaction. So the Blaise reaction products are very much useful in the Bisnelli, very popular reaction. So all the researchers can think in such a way that how can we convert the nitriles into the corresponding beta keto esters to produce a variety of dihydropyrimidinone derivatives. Okay, thank you very much.